So in this question, we're just exploring the definition of the probability of A given B. So to explore this, we're just going to write down our formula. So we have the probability of A intersection B, and this is going to be over the probability of B. And this is a formula I'd recommend you learn off because it's very useful. And this is something we're going to rearrange shortly as well. But just to help us understand this concept a little bit more visually, if we had a Venn diagram here of A and B and there's some overlap, that means the intersection actually exists if there is overlap, then we can just shade this in. And this is going to be the probability of A intersection B. And if this is A over here on the left and this is B on the right, then what we're essentially finding is a fraction of this overlap compared to the rest of the area. So compared to the overall area of B, which would include this intersection as well. So that's what this division is actually going to achieve. And the area of Venn diagrams isn't something we think about too much, but you could represent this in terms of area, and that's what the fraction would mean more visually. And if we just also look at the fact that these are independent events, this also tells us something about how we can rewrite the probability of A intersection B. So in the previous question, we were exploring the fact that you can actually rewrite the probability of A intersection B as the probability of A multiplied by the probability of B when they are independent events. So it is very important that these events are independent if we're going to actually rewrite the probabilities in this fashion. So when we just rewrite the rest of the fractions, so where we had on the left here probability of B on the bottom, you'll see that because we've got a probability of B on the top and one on the bottom, we can actually cancel these two out. So this is going to cancel with this, and we're left that the probability of A intersection B is actually the same as the probability of A in the case of A and B being independent events. And this makes a lot of sense because independent events would mean that the outcome of one event doesn't affect the other, and the probability of A given B already happening should be the probability of A if the events are in fact not dependent on one another. So that's it for this question.